We've seen the concept of lagging and leading, right? In each circuit diagram. If it is resistor, inductor, or what? Capacitor, we've seen how it works, right? Now, let's see when your resistor and your inductor, they are together, meaning they are in series. Let's see when your resistor and your capacitor, when they are in series. And lastly, let's see when your resistor, inductor, and capacitor are in series. Back to the subtopic, application of complex number to what? Series AC circuit. These are the AC circuits, but they are in what? Series. The same way we have for series, we also have for what? Parallel. This circuit diagram, let's say we are in normal AC series circuit class. This is my diagram. This is the formula for my impedance, right? Let's say we are in normal AC series circuit class. Complex number is not attached. Let's say we are just in series AC circuit class. This is my formula. This is the diagram. Do you agree with me? This is the impedance. You know what impedance means? We've defined that. The combination of your resistor, and be it inductive resistor or capacitive resistance. You get what I'm saying? Now, this is your impedance for this circuit, right? Now, this is also your impedance for this circuit. You get what I'm saying? This is also your impedance for this circuit. But now, we want to apply complex number. We want to what? Apply complex number. So, what you've stated previously, all those things that you take note, you implement it now. All those things that you take note, you implement it. Now, for complex number, for your number to be a complex number, it must have what? Real part and what? Imaginary part. Meaning you are going to modify each impedance in each circuit diagram. You modify it to be a complex number. You know, let's say you are given that you already know the value of R to be 4 ohms, and you already know the value of XL to be 4, what's in it? Ohms. You already know the value of R to be 4 ohms, the value of this to be 4 ohms. You know, writing your Z, this is what you have, 4 plus 4. True or false? Now, say you are writing your Z as 4 plus J4. What's the difference? This is complex number, and this is just a number. So this is where this subtopic comes in. This is where it comes in. This is where you apply complex number. Now, for this circuit diagram, you apply complex number. For this circuit diagram, you apply complex number. For this circuit diagram, you apply complex number. You apply complex number. Now, meaning, what we know, which is this guy, as far as this topic is concerned, under complex number, it becomes Z equals to what? R plus J XL. This is the real part of your impedance, and this is the imaginary part of your impedance. Similarly, if it is this circuit, this becomes your formula or your equation. Z is equals to R minus J XC. Always take note, for RL it is positive, RL it is positive, RC it is negative. Always negative, and this is what? Positive. Now apply that concept here. This becomes Z. Okay, before then, I would love you to tell me this. Observe something from here, from this first one. Observe that your capacitive reactance and inductive reactance, they are the one taking the imaginary part. They are the one taking what? The imaginary part. Now apply that idea here. This becomes what? Z equals to what? R plus J, all into bracket, XL plus XC. Yeah, this is correct, but at the same time it's not correct. What we want to use is that we have XL being positive here, and we have XC negative here, meaning XL minus what? SC. XL minus FC. In essence, you'll be given a question. Your first task is that question, compare it to the standard form of your impedance. Given a question, identify this question given to me. Is it RL series circuit or RC series circuit or RLC series circuit? If it is RL series circuit, we call this formula. This is the standard formula. So meaning, this will take you back to equal complex number. Do you recall what equal complex number says? It's just like your algebra. Say you have that Z1 is equals to Z2, and Z1 is defined as A plus JB. Z2 is defined as C plus JD. From here, comparing the left hand side and the right hand side, A is equals to C, B is equals to D. So given any question, you are comparing this impedance of this circuit to the question given. using equal complex number. We take an example to see what we are saying. Just take note, this is your formula for impedance for RL series circuit. This is your formula for impedance for RC series circuit, and this is your formula for impedance for RLC series circuit. This is just impedance. You know, for AC circuit, we have different parameters. Out of these parameters is what? Impedance. And we look at impedance. Now, the next one is what? The next one is what? Current. Ohm's law, right? Yes. By Ohm's law, what do you know from Ohm's law? We know that from Ohm's law, V is equals to what? IR. Call this equation 1. Equation 1, in place of R, substitute what? Z, right? Meaning, are you know what I'm saying? Impedance, you are using impedance. So we have V is equals to IZ. Call this equation 2. From equation 2, you can derive, this is from equation 2, this is the formula for voltage, right? Now, let's get another formula from this equation. Say, formula for I. What's the formula for I? V over Z. Call this equation 3. From this same equation, let's get the formula for Z, impedance. That will be what? Z is equals to what? V over I. Meaning that you apply, depending on the type of question given to you, you apply equation 2, 3, call this equation 4. You apply equation 2, equation 3, equation 4 to this circuit diagram. You apply it to this circuit diagram. You also apply it to this circuit diagram. So we've seen the first one and the second one. Then the third one. Now observe my diagram. Observe my diagram. For this RLC circuit diagram, I have the net voltage, right? I have the net voltage and I have the voltage passing through each element. For this resistor, this is the voltage passing through it. For this inductor, this is the voltage passing through it. Meaning, depending on the question might say that calculate the voltage. Yes, calculate the supply voltage across R. The question won't be specific. Let's say R is defined to be 6 ohms. The question will just say that calculate the voltage across 6 ohm resistor. What it means is that you have to calculate VR. I get what I'm saying. Similarly, question might say that calculate the current passing through this inductance. But just have it in mind that the summation of VR and this will give you this voltage. Now, by formula, to get the net voltage here, this is your formula. Meaning the voltage across this resistor plus the voltage across this what? Inductor. I get what I'm saying. So, just to know, you know, before you submit your script, it's something that you should possibly, it's something that you've calculated your answer. Abi, like this thing, I will definitely get it. Even after your exam, when you see your score, you won't be surprised. So you can just do some checking. So if the question says that, if this one is given, if you are giving this one from the question, and you just want to calculate this one, and you've calculated this one, you know you are done, right? But at the same time, you can just do this at the back of your book. By the time you calculate this, sum it up, it will give you this one. So if you are getting this one, it means you are correct. If you are not getting it, it means the value you've gotten for this is wrong. So quickly check yourself. Hope you are getting what I'm saying. Yeah. So this is the formula, meaning the net voltage here is equal to the voltage across each resistor, each circuit element, which is this resistor and inductor for this RL series circuit. Now, for RC series circuit, this is your formula. Since you are using complex number, so I'm having real part and imaginary part. So this is it. Then for RLC series circuit, this is it. So that's all. We also have we thought this that we discussed in the morning. We said we also have phasor diagram. When we started, we said the first thing that we'll be looking at is what? Circuit diagram. The number 2 is what? Phasor diagram. Then lastly, Argand diagram. Just know that our phasor diagram is plotted on Argand diagram. We use Argand diagram to plot phasor diagram. So then the last one is phase angle. Yes, phase angle. We'll be looking at phase angle too. But what I'm going to do is that we are going to solve a question. So that question, the question will ask us to draw the phasor diagram and calculate the phase angle. So with that idea, we are going to understand the concept behind phasor diagram. So we've been able to explain our circuit, right? And we've taken note of those formulas. All right, now let's take down our first example.